In this video, we'll be just dealing with the resultant velocity at any point in time. So that'll be the magnitude of the velocity at any point in time and the angle in both radians and in degrees. So what that means is at any point in time, the velocity is made up of these two horizontal and vertical components. So we're going to use Pythagoras to add them together and work out the resultant velocity, and use trigonometry to work out the angles. So in the spreadsheet, we can see that the initial velocity is 25. So we've broken down that initial velocity into its horizontal and vertical components. So in this part of the table, at 0 at the initial launch moment, these are your, well, rounded up, as you'll see, these are your initial horizontal and vertical components. So they should then add to give 25 meters per second with radians of 0.646 and an angle of 37. Let's use our formula. So we're going with our resultant velocity equals the square root of the horizontal velocity component squared plus the vertical velocity component squared. And then we can just copy that down. The angle in radians should equal the angle of the initial velocity here, because we're at times 0. We enter equals, so we're saying theta equals, and it's a tan, which is the inverse tangent, and it'll give it in radians. So it's the vertical velocity divided by the horizontal, and it's the same. And now we just convert radians into degrees. And it's 37, just like the initial. So we can just select, click and select both cells and drag them down. And that's it.